I'm going to talk about from hydrogens to neutrons. Ian did mention why have I put hydrogens? Well, hydrogen is H2. There's definitely two hydrogens in hydrogen. So it is definitely from hydrogens to neutrons. And I started in Supergen right back in 2003 when the first UK Sheck was produced. And that's me down in research co-investigators, Dr. M.O. Jones. And you can see this is the list of investigators from that proposal, and you can see it's a huge number of people and quite a diverse list as well. And I was involved with Peter Edwards. My role was really in helping with the assembly of this proposal, which was quite a unique procedure, because it was, I believe, at the time the first research grant that combined physical sciences with the social scientists. Which certainly gave us an interesting agenda about how the grant should be assembled. And if you look at the text that's associated with it, this is the abstract from that proposal, and it's quite short and quite pithy. And when that came to an end in 2007, we of course applied for the extension for Sheck 2. And we were awarded that again in 2007, which ran for a further 5 years. And again, we have a very similar set of investigators. I will point out that I've now been moved up a step into other investigators, so a promotion of some kind. The real interesting thing here is the abstract from the proposal is now quite a lot bigger. So the breadth of what we're trying to cover in this second Sheck was much wider. And at the same time, we also had the good fortune to be involved with the Supergen biomass proposal as well. Now, I mentioned these and the diversity of the people involved for one particular reason, and that's to do with my new job. So my current role is here at the Rutherford Appleton Laboratory, nestled in South Oxfordshire. You can see the cooling towers there from the Didcot Power Station, which no longer exist, and the beautiful weather in Oxfordshire, almost exactly how it is today. In fact, it's absolutely boiling. And I work down here in this bit, which is ICIS, which is the UK's neutron and muon source, where we run a whole set of experiments for characterizing materials and material systems. And this is up close. So we have a low energy cyclotron for accelerating protons, which are smashed into tungsten targets at about 85% the speed of light, and that process produces neutrons. And what we use those neutrons for is looking at materials. And what we want to do is we can look at the structure and morphology of materials, either as powders or in liquids, or from surfaces by reflectometry or by imaging and tomography. We also want to look at the dynamics of these materials. We look about how the atoms within or the molecules within them move. We do that by spectroscopy or by muon spectrometers. And in addition to all these instruments we have for analysing materials, we also have a suite of secondary laboratories where we can do secondary characterization studies. So we have biological laboratories, physical chemistry laboratories, catalysis laboratories, even hydrogen laboratories. So we really are a centre for materials characterization. And neutrons are a kind of a specific probe. We don't really have time here to discuss the advantages and disadvantages of using neutrons to characterize your materials. But if anyone is interested, then the organisers will be able to give out my email address, and I'd be happy to interact with you. But what do I do at ICIS? Well, I am the Energy Materials Coordinator at the ICIS Neutron and Muon Spallation Facility, which is a very grand title. And basically my role is to go out into the community and talk with scientists working in the field of energy materials, which for me is as broad as you want it to be, everything from structural materials through hydrogen storage to catalysis and back again, and to talk to those people about what their current challenges are in characterizing those materials, and to see if we can't use our neutron facilities to actually help alleviate the problems they have with their current material systems. And one of the reasons why these Supergen partnerships was so useful for me, when I moved to ISIS in 2011, I had, little did I know it at the time, I had a great network already set up by the Supergen facility. So I knew a lot of the very important people working in energy materials in the UK already. And so that allowed me to go out and see these people and discuss with them their research and see how we could try and facilitate that research using the Rutherford Appleton Laboratory. And so some of the things we've done is we've developed combined microwave and neutron characterization methods. We've done that for looking at sensors for ammonia detection, ammonia storage material, looking at clean air materials that can pull carbon dioxide and SO2 out of gas streams. I've also been working with the energy materials community to develop new characterization facility, expertise and capacity, developing characterization methods for hydrogen and ammonia storage systems, developing neutron characterization methods for battery materials as well, as uninterested as most people are about that. That is actually a very large growth area given the current UK government investment in batteries, and developing neutron characterization methods for flow bed catalysis systems, which Ian, of course, knows quite a lot about. And some of those systems are shown here. So this large box on the left is something that we developed directly out of a UK SHEC, and this is an intelligent gravimetric analyzer for measuring hydrogen uptake and desorption from materials dynamically in a neutron beam. So what it allows us to do is to perform gravimetric hydrogen uptake measurements whilst looking at the structure of these materials, and to cycle our material and collect data on the structure simultaneously. And it gives you a great deal of both thermodynamic, kinetic and structural information in a single experiment. The next two images here, these are a piece of apparatus developed in conjunction with St Andrews University to look at ionic mobility, predominantly H- mobility in these materials which have potential as membranes. And this kit is actually designed to go both in neutron diffractometers to look at the change in structure as you put hydrogen in and take hydrogen out, and also into something called QENS, which is quasi-elastic neutron spectroscopy, which allows you to determine the motion of those ions through the solid. You can determine how they move, what the mechanism for that motion is, and also what the barriers for that motion is as well. And the third one is something we've developed with Cardiff University, which is essentially a microwave dielectric resonator, which measures the dielectric properties of materials as we pass a gas through, and that gas is absorbed within it. And simultaneously, we can put the neutron beam through it and we can look at the change in structure. And this has been incredibly useful for looking at materials that absorb things that are very polar, such as ammonia or SO2, or for looking at changes in structure and dielectric properties of materials that absorb CO2, as we've done with C. Yang at Manchester. And these are just a few of the pieces of kit that we developed over the last 10 years to try and facilitate the energy materials community in the UK. And quite a lot of this has come out of the stuff that we originally did back in UK SHEC and the networks that were set up in that programme. So how can we progress? Well, I've only got two things to say here. Obviously, I'm going to suggest that we work with national facilities. There are lots and lots and lots of opportunities for unique experimentation at national facilities. And that's not just ISIS with neutrons. It's also at the Diamond Light Source with X-rays, at the Central Laser Facility, at the Catalysis Hub, at the National Microscope Facility. All of these places have lots of opportunities for unique experimentation. And if you're lucky, for funding. There are funding opportunities there that can be taken advantage of, that will allow you to, for example, pay for students, and if you're very, very lucky, even postdocs. And the second thing is to talk about these supergens. And these supergens are truly interdisciplinary and multidisciplinary, and they promote national and international collaborations. And I've spoken already a little bit about the national collaborations that I've been able to develop on the back of the networks that Supergen produced. But as previous speakers have mentioned, DOE, IEA and HIA, the Supergen cache allowed me access to DOE, IEA, and HEIA, and some of the partnerships that have developed from those international collaborations have been very successful as well. So, you know, these Supergens are not just here to fund individual pieces of research. It's at the boundaries between research groups that the real progress and the real interest, I think, is made, and the connections and the networks that you can build from being a part of these groupings. Anyway, that's enough waffle from me. I'd just like to thank you all for listening to my brief advert for ISIS. And if you have any questions or you want to talk about the potential for neutrons in your own research, please do drop me an email.